Hi, this is Tom. Welcome to my channel. Have a little math to show here that I think is kind of fun. And I'll start with, there's 3 tabs to this demo that you can, I'll include the URL in the description of the video if you want to play around with it. I'm going to start with the number line patterns. And I'm going to start with a midpoint of 1. So the distance from the endpoints is 2. And what this will show is if you choose 3 numbers in a row that are separated by the same number. So like 1, 2, 3 or 0, 2, 4. Let me choose a higher number here. Let's choose 10 for the middle one. All right. So we got 9, 10, 11, 8, 10, 12, 7, 10, 13, 6, 10, 14. The spacing's the same for the jump of the 3 numbers. That's what we're getting at. So let me go back here. I'm going to start with 1, 2, 3. Here we've got 1, 2, 3. So the first thing to notice is if we multiply the endpoints and add 1, we get a square. So 3 times 1 is 3 plus 1 is 4. That's a square. 3 times 5 is 15 plus 1 is 16. That's a square. 4 times 6 is 24 plus 1 is a square, 25, and so on. Any 2 numbers separated by 2, like 14 and 16, that's 224. Any 2 numbers, you take the product, add 1, 225, you get a square. Okay, and let me show the same thing with jumping by 2s. So 2, 4, 6. 2 times 6 is 12. And now here we're going to add 4. So anytime you have 2 numbers separated by 4, you multiply them together and add 4, you get a square. Let's try another one. So 3 times 7 is 21, add 4, you get 25. That's a square. 4 times 8 is 32. You add 4, that's 36, you get a square. Any 2 numbers separated by 4, multiply together and add 4, you get a square. Okay, let's look at one more. We'll look at 3. So for hopping up by 3s, then the endpoints that are separated by 6. Anytime you take 2 numbers that are separated by 6 and multiply them together, if you add 9, you get a square. So 3 times 9 is 27. Add 9, 36. That's a square. 2 times 8, these 2 are separated by 6, is 16. Add 9. That's 16 plus 9 is 25. That's a square. Look at one more. 1 and 7 are separated by 6. Multiply them together. You get 7. 8, 9, 16. That's a square. Okay, so that's one thing to see. And then another thing to see is that not only do you get a square, but you get a square where the square root is the midpoint of the 2 numbers that you're looking at. So if we go 3, 4, 5, then we have 3 times 5 is 15, add 1 is 16. Take the square root as 4, right in the middle between 3 and 5. So I'm not going to go through all the variations here, but you can play around with this if you like. And this will show this what's happening there. And look real quickly at the algebra involved here. So the algebra is, we call the midpoint C, and we'll call the distance that you're hopping up by A. So this endpoint will be called C minus A, and this endpoint is C plus A. So if we multiply the endpoints, that's C minus A times C plus B. That's shown right here. Okay, so C minus A times C plus B, actually that's right here, equals C squared minus A squared. So if you add A squared to that, you get C squared. So this is the algebra for multiplying the endpoints and then the square of the distance to get the midpoint squared. Okay, so the next thing that I want to go to is a geometric representation of this. which this was really the motivation for this video, is I really like this idea here. Because I came up with this because I wanted some way of being able to mentally visualize this identity. And also, we'll see in a moment here why I chose these numbers to be C and A. All right. So we've got the same number line here. And here we're choosing C to be 5, and we're hopping up by 3s. So A is 3. That's the difference from 2 to 5. And also from 5 to 8. We're hopping up by 3. So A is 3. And then C, the midpoint is 5. One endpoint is 2. 5 minus 3 is 2. The other endpoint is 8. 5 plus 3 is 8. Okay, and here is the geometric representation. So here we have A squared, and then here we've got this boomerang, which we'll look at in just a second, and then the big square is C squared. Okay, so what is the area of this boomerang? Well, if we look at the width, we can see that the width of this square that I'm outlining here is C minus A. Sorry, not a square, it's a rectangle. The width of this rectangle is C minus A, and that's also the width of this other rectangle, C minus A. So this rectangle is C minus A times C, because the length is C, and the width is C minus A, that's this one. And then the area of the other rectangle is C minus A again. This width is C minus A, because the whole thing is C, and this is A. So this is C minus A, and then the length is A. So here we've got C minus A times C. Here we've got C minus A times A. So we've got C minus A times C minus B. That is the area of the boomerang. Or another way to see it is just imagine that this part of the rectangle is flipped up here. So you've got one big rectangle like this, and then so you're going to have C minus A times C plus B. That is the area of the boomerang, C minus A times C plus B. So that is a geometrical representation of the identity that we're talking about. We've got A squared, that's this square here, the distance from the midpoint to the endpoint. This is the number line that we're looking at here. This is the endpoints are C minus A and C plus B. This is the midpoint of C. So this is a visualization of the square of the distance from the endpoint to the midpoint. And this big square is a visualization of the square of the midpoint. And then the boomerang is a visualization of multiplying the endpoints. So this is showing a way that you can visualize geometrically that A squared plus the sum of the product of the endpoints equals the midpoint squared. Okay, so why am I choosing C and A for the letters? The reason for that is this gives a nice representation of the Pythagorean theorem. Because here, if we let the boomerang be B squared, we've got A squared plus B squared equals C squared. Excuse me. So as long as we choose C minus A and C plus A in such a way that that product is the square of an integer, then we're going to have A squared plus B squared equals C squared. So we can ask the question, well, how can we do that? How can we choose C minus A and C plus A so that their product is a square? Well, one obvious way of doing that would be to choose C minus A to be a square and C plus A to be a square. So let's look at this. So here we've got c minus a is 1, and we've got c plus a is 9. So these are both squares. And so the boomerang is a square, and we have an area representation, or a visual representation of the areas of a squared plus b squared equals c squared here. So anytime you choose an even number, you'll get 2 squares for the endpoints. And you can do this a squared plus b squared equals c squared representation. So that's what this is showing here. And you can go through the algebra that it's showing here. And for an odd number, you can do the same thing, but in a slightly different way. What we'll have, by the odd number, I'm talking about a is odd. So if a is odd, we've got the difference from 2 to 5 is odd. It's 3, which is odd. So in this case, the endpoints will be 2 times the square on each side. So 2 times 1 and 2 times 4 we have here. 2 times 1 and 2 times 4. So we get a square because we have 2 times the square on the left side, 2 times the square on the right side. So if that gives you 2 times 2 times 2 squares. So you get a square. You're going to have 2 times 1 on this side, and 2 times 2 times 2 on this side. So that's 2 times 1 times 2 squared is what the boomerang area is. And again, you can play around with this. You can choose different odd numbers. And then I'll explain something else here, which is another way of looking at the algebra here. Is let's say that you're on this square here. So this is a squared. And let's say I'm a. And I want to know, okay, what do I do to myself to get up to c? And the answer is, so I'm a, I'm 3. I'm the distance between 5 and 2. How do I get up to 5? So I want to get up to a c that will work. A c that will be a squared plus b squared equals c squared. What do I choose for c? And the answer is I square myself and add 1 and divide by 2. So I'm 3 here. So 3 squared plus 1 is 10 divided by 2 is 5. So if I choose that, then this will work. The math will work. I'll get a squared plus b squared equals c squared. Now if I'm even, then the math is I divide myself by 2 and square and add 1. And then if I do that, then I'll get a c, which works. The a squared plus b squared equals c squared will work. And if you're interested, the page is showing the algebra involved on why that works. Finally, one last application of this number line idea. This is the exact same representation that we just saw, the visual representation, but I'm doing a different application here. So the application that I'm doing here is to do mental math of squares. So I'll explain this. Let's say I want to know what 13 squared is. So 13 squared, I'm going to choose 13 for the big square. That's the big square, is 13. So C is 13. And then I'm going to divide the area into another square and a boomerang. So the boomerang represents the sum of the products. And then you have the small square is the distance from the midpoint to the endpoint squared. So this is the same identity that we were looking at, where you have the product of the endpoints, c minus a times c plus a, plus the distance squared from the endpoint to the midpoint equals the midpoint squared. So this is the visual representation of that. And then what we're going to do is for any square we want to mentally figure out, we just choose a nice number for the small square so that the math is easy. So I'll give a couple examples of that. So if we do 13, if we choose 3 for the small square, 13 minus 3 is 10, and we get 10 times 16, 160, that's easy. Add 9, 169. So let's try 17. Okay, so if we choose 17, then we'll choose 3 again, and we get 17 and 20. That's, we go up to 20 from 17. The product of the endpoints is 20 times 40. That's 280. That's easy. And then we add 9. That's 289 is 17 squared. So you can look at it in 2 ways. One is you can just think about the number line. That's easy to do. We're saying we want to know what 17 squared is. So we do 14 times 20, which is 280, and add 3 squared, which is 9. We get 289. Or you can think of the visual representation of the geometrical representation. So let me give another one here. I'm going to use 37 here. And here I'm going to choose 13. Okay, so the reason I'm choosing 13 is to get up to 50. Because 50 is really, really easy to multiply by. Because for 50, all I need to do is add 2 zeros and divide by 2. So if I multiply 50 by 24, that's 1,200. Because it's 2,400 by 2. So 1,200, I can take even easier. Just take the number that you have as the endpoint. Divide by 2 is 12 and add 2 zeros. 1,200. And then we just saw that 13 squared is 169. So 1,200, 169 is 1,369. So let's try a couple of others. Let me try 97. Okay, so here's 97. And I'll make this a 3. So it's kind of smushed this together here on the number line. But we want 97. We add 3 to get 100. We subtract 3 to get 94. And this is 9409. Very, very simple. Let me do another one. I'll do 92. And then I'll make this 8. Okay, good. This is enough distance where we can see it here. So I choose 8 to get 92 up to 100. And then, so that's 100 times 84 is 8,400. Add 8 squared, which is 64. You get 8464. Did I do that right? Yes, 8464. Okay. Now you can use this method to do, it works terrifically for 2-digit numbers. If you get the squares from 1 to 25 down cold, you can very quickly multiply any 2-digit number in your head, because you can just choose 50 as one of your nice numbers or 100 as one of your nice numbers. So I'll give an example of that. Say I choose 87. Okay, so I'm going to choose 13. Okay. And then I have 100 is one of my nice numbers. And then 74, if I subtract 13 from 87, that gives me 7,400. I know 13 squared is 169. So I add 169 to 7,400 to get 7,569. So you can do any 2-digit numbers, square them quickly in your head by getting that down. Now, I think this will do 3-digit numbers. I don't know why it wouldn't. So let me show an example with 3-digit numbers. Let's say I want to do 113 squared. Okay. And so I can do the same thing. I can do 100 times 126, 12,600, and add 13 squared, 169. And then I get 12,769. So if you get the 2-digit numbers down and called, then you can do any 3-digit number pretty quickly. So let me give an example of a hard one. So probably the hardest one I can think of would be something like 887. So if I do 887, I'm still choosing 13. That gets me up to 900. And so I do 900 times 874 to get me the one product, 986,600, and I'm adding 169 to get 786,769. So this one is obviously a bit harder, but it's not as hard as it looks, because when you're just doing 9 times 874 and adding 2 zeros. So it's just a single number 9. So in your head you can do 9 times 8 is 72. So that gives you 7,200, and then you add 63, and then you add 36. It's easiest to do it from left to right. And then you can get your number 7866, just add 2 zeros, add the 169. So it does take some practice, but with some practice, you could get to where you could do this, and pretty quickly, less than 30 seconds, easily, if you spend like a day practicing that. And then I found, this would be a subject for another video, I found that when you get to 4 digits squared, then there's another method that you can use, which is as easy as this one, but you can use this other method to do any number. Like, I'll do a video sometime, hopefully, on how to square a 10-digit number in your head, but that'll be another video. Okay, well, that's what I wanted to cover in this video. And one other thing I want to mention is I did all of this using Gemini 3 Pro. It was very easy to do. And if you're interested, anyone can do this. I'll show how to do this. And if you're interested, then just look for the next video after this one. And thanks for watching. Until next time.